Welcome. Uh, this is Mr. Renu. My name is Fred, and as you know, we are organizing for a competition. It's called Soccerbots Competition, whereby we have several categories, and one of the categories we have soccer bots, whereby we are going to engage robots play football, and we have other categories like racing bots, whereby those are just robots which are going to race and they're going to compete and are going to the fastest robot is going to emerge the winner. We have several other categories like battle bots. These are robots which are going to literally they are going to fight, and the robot which will be declared immobile, the robot which will be immobilized, it will be declared the loser. Then the counterpart will be declared the winner. Among the categories, we also have maze solving bots. These are robots which are going to solve a maze. Maze is just like a path which have several dead ends and other zones which the robot can be able to find way from the start to the end, but it has some tricks. So the robot should intelligently look for the way out. Then, in case it finds way out, then it will successfully find that, solve that maze. Yeah. So basically that is it, and I just want to start with these maze solving robots for the next few minutes. So we are going to discuss about maze solving bots, because the last event we had around over 230 participants, of which 25 of them had their own robots, and we only had one category, unlike now where we are having several other categories. So many of the feedback we were getting from the attendees, they were requesting if we can train them on how they can make the robots. So this is one way of which we are going to make the robots. The way I'm going to help you and them to build a robot. Yeah. So basically that is it. Let's just make a robot in this category. We have maze solving robots, and in future we are going to do other categories. Yeah, so let's just get started. Just a minute. Let me confirm if I am live. Okay, right. Yeah, we are there. So let's continue. So these are my slides. These are just my slides. So Extrabotics maze solving robots. So number one, we're going to tackle overview. We're going to check the overview of the robot and this category, the components used, algorithm, coding and calibration, navigation and testing, optimization and enhancements. Yeah. So let's start. This project is all about building an Arduino-powered robot that can find its way through a maze on its own. No? Over the next 4 days, we are going to break down the process step by step, from wiring and coding, testing, from the problem solving. By the end, you'll have not just working. Sorry. By the end, you will. Sorry for the noise. By the end, you will have not just a working maze solver, but also hands-on experience in robotics, sensors, and smart algorithms. Yeah. So what is a maze solving robot? It's an autonomous bot that finds its way out of a maze. It uses sensors, and algorithms. For example, algorithm, we're going to use wall following, and while following we have two approaches. We have using left hand rule, and we can also use right hand rule. Then we have another called flat fill, that is advanced one, and also we have other algorithm called search algorithms, which are also so advanced. We are not going to tackle the two last ones. So that is it. The circuit, we are going to also tackle about circuit and build. We are going to build, we will construct a basic robot. The basic robot will either be 4-wheel drive or 2-wheel drive, but basically for maze solving, it's better you use 2-wheel drive because it's very easy, simple and easy to corner and to maneuver around. We have options to use any microcontroller of our choice. For example, we can use Arduino, we can use Raspberry Pi Pico, etc. We'll opt for Arduino Uno. We will use a 2-wheel drive robot for the demonstration purposes. So, understanding the maze solving robots, we are going to define what they are, what is a maze solving robot, how do you build it, and algorithm for navigation. What is the algorithm are we going to use for navigation? What is the algorithm for navigation are we going to use? Hardware, uh, microcontroller and sensors we are going to use. Yeah, then the circuit connection, that is it. We're going to see how do you connect the components, the motor driver, the Arduino and whatnot, the sensors, the motors, all that. How are you going to do that? Yeah, so the coding and calibration, we are going to see how do we code it, how do we write the code, which programming language are we going to use to code this thing. Yeah, that is it. And yeah, we are going to use Arduino programming language, which is made up of C and C++. Yeah. The code structure of Arduino programming language is usually we usually define, assign, and execute DAE. Yeah, that is the code structure. But the major code structure is we have only two parts. We have void setup and we have void loop. Yeah. So basically, void setup is whereby we run our code to just run once. Void loop, our code will repeat itself forever, like it will loop itself. Then we have sensor calibration. Sensor calibration, we're going to calibrate those sensors, the IR sensors and the sensors we are going to use. You can also use LDR, but that is not that efficient because of the lighting and yeah, something like that. But we are going to use IR sensors. So the motor control and fine tuning, we are going to do some fine tuning on the motors, the control turn, U-turn, left turn, right turn, proceed straight, like that. Yeah. Then we have navigation and testing. We are going to test our robot on how well can it navigate, can it find the best route, can it find the shortest route. Yeah, like that. Mkubwa. Masaa ishafika, ni mimi tunangoja kidogo niende. Yuko kesho na kesho kutwa, ni mpaka Monday. Sawa. Navigation and testing. Yeah, so we're going to tackle on that. Yeah, then the maze solving logic. Yeah, the maze logic. Which logic are we going to use? Yeah, we are going to see that, but that you have to implement in the code. And the conditionals. Those are just conditional statements. If, else, yeah, something that, but that should be on the code. The robot decision making. How well can a robot make decision? Yeah, something like that. Testing and adjustment. How are we going to test the robot? Yeah, and just adjust some parameters of adjustment. Fine tuning, we are going to fine tune all those parameters we are going to fine tune in case we see the robot didn't make left turn. It was supposed to make left turn then, but it made a right turn, or it proceeded straight. Now we need to fine-tune that on that, so we are going to do that. Yeah, also, yeah, our target audience, this tutorial is designed for students eager to learn robotics, hobbies, passionate about building, and makers who love creating with their hands. Yeah, so basically if you are out there and you'd like to venture in this field of robotics and automation, and also DIY using electronics, you can join our session. Our session will be running every day for the next 2 days now. Okay, we started yesterday, and yeah, for the next 2 days or three, we are going to tackle on the maze solving robots category, and it's free of charge. Then also we have our upcoming event on 20th September 2025, so make sure you reserve your ticket. You can also join our WhatsApp channel and our WhatsApp community, where we usually post the updates there, and also we can discuss on how you can build your robot and whatnot. Yeah, the students, our target audience is students step into the world of robotics. We are going to usher students into the world of robotics. So if your student has no prior experience, there is no prior experience which is needed. Let's assume they don't have any knowledge in robotics. This is the best place they can just turn their curiosity into actions. Yeah, so we're going to turn classroom concept into real world problem solving using we're going to use robotics and maze solving. Yeah, so robot enthusiasts also we can use you robot enthusiasts, you can come in handy. Yeah, by just coming up with your own robot. Maybe let's say you have been building robotic solutions but not yet robotics for robotics competition. You can come in handy. You can just join us and make your own robot. Then we're going to compete with other robots. Yeah, so we want you to build robots that can think and move on their own without any human intervention, without being forced. Yeah, you can just make your own robot. You place it on the start, then you switch it on, and we just observe the robot do its thing and maneuver, find its way to the finishing line, finishing spot. Yeah, the future competitors. So the major reason we started these meetings is that most of people have been requesting, we don't know anything about robotics, can you teach us? Then next time we are going to come up with our own robot here. Yes, so you can join our class, our sessions, and we are going to learn a lot, so that you can compete in the next one. So let's dive in. Let's build a maze solving robot. We can decide to the features and the efficiency of a robot, which will be decided by the components we use, such as sensors like ultrasonic sensors, IR sensors, either LDR, the best which can work well, infrared cameras. You can also employ machine learning, and you can employ something called computer vision using OpenAI and Raspberry Pi. Yeah, to map the surroundings. Yeah, algorithms you are going to use will also depend. We will also decide on the efficiency of your robot. Yeah, like advanced like depth first search. Yeah, breadth first search. Wall following, that is very simple for a beginner. I think wall following will do good to map the maze and choose the optimal path. So yeah, the algorithms. So this is our last slide for this part one. An algorithm is simply a step-by-step set of instructions that a robot or computer follows to solve a problem or complete a task. In robotics, algorithms tell the robot what to do in every situation. For example, a T-junction, a crossroad, or a dead end in the maze. Yeah, think of it like a recipe for the robot, clear rules, clear actions, no guesswork. So yeah, algorithm is just a step-by-step set of instructions that the robot or computer will follow. Yeah, it must follow that to either solve a problem or complete a task. So we have several algorithms and we have options we can use. We can use option one, we can use while following. While following, we can use the left hand rule. The robot keeps one hand, that is the left. So it's basically I just want you to picture in your in your mind, like you see the way you enter your room and maybe there's blackout, there is no lights. The way you usually maneuver by using your hand to like feel the wall or to find the way, that is the way while following left hand rule will work. The robot keeps one hand, that is the left, virtually, okay, we are imagining it has hands, the left in contact with the wall while moving. This guarantees finding an exit in simply connected mazes, no loops, but may not give the shortest path, because by then we are going to see this. Let me not just explain right now. So also we have another option for wall following. We have a right hand rule. Hand rule is the opposite of the left hand rule, because the robot now will use the right hander to maneuver to find the way. That is option number 2. Option number 3, we can use depth first search. I'm not going to details for that. The robot explores layer by layer, checking all neighboring paths before moving deeper. Always finds the shortest path, but it requires more memory to store visited nodes. So it has to store, like it found this junction, it stores that to the memory so that it doesn't repeat the same. So we have another algorithm called pathfinding. So just a minute, let me confirm if everything is okay. So pathfinding, sorry, just a minute. Just ignore that customer engagement. I was supposed to edit that in the slides. I forgot. So the robot calculates the optimal path from start to goal. They consider distance, cost, and obstacles applicable for real-world autonomous robots. Yeah. So these are advanced robots, not just basic robots. Yeah, because now we are talking about cost. Yeah, that is it. And in case you have any question, you can ask. The components we are going to use. So in the next part, we are going to talk about the components we will use. And yeah, the components needed to make a maze solving robot. We can use Raspberry Pi Pico, as I mentioned earlier, Arduino, ESP32, ESP8266. We can use STM boards. We can use other advanced boards like Lego, Spike, Prime. We can use any microcontroller or any other able microcontroller. The reason I use able microcontroller is because we have other microcontrollers which are dedicated to certain tasks and cannot do fully the tasks for line following and whatnot. So we will use an Arduino microcontroller for its simplicity, popularity, and ease of coding. Arduino is very much coded and it's well documented, so it's very simple to get some tutorials on that and some codes. So in the next one, we are going to discuss on the components, bill of materials, the materials we need, and other requirements we'll need for us to build these maze solving boards. So make sure you follow along and make sure you register to participate in that maze solving boards competition. So thank you for joining, and you can always follow our WhatsApp channel and join to our community by just clicking on this link or just scanning on these QR codes. You can pause and take your phone and scan these QR codes. They will redirect you to the WhatsApp community and WhatsApp channel. And you can also copy the link, type the link in your browser. I'm going to attach the link in the description. Then you'll be able to join our WhatsApp channels. Thank you. You can also follow me on TikTok. That is the username, and you're going to learn more about what we do. Thank you for joining. Make sure you join our community because I'm going to send the future links for other events there. Bye bye.